All right, this is a z-score problem, and it's from the specimen paper from paper 2. But I want to do this because I really want you guys to see a z-score problem prior to taking the test tomorrow. And so, first of all, my first question is how do you know that is a z-score problem? All right, so the key to this is that it says normally distribution. It talks about a mean and a standard deviation. Okay, those things tell you that this is a z-score problem. All right, so first of all here, they ask us to sketch the graph of the distribution with these weights. Now, we're not going to do that empirical stuff. Only do the empirical stuff if they ask you to do an empirical rule stuff. All right, only if. All right, so let's just go sketch my distribution. Okay, I have my bell curve. I'm going to label my mean. My mean is 55 with a standard deviation of 7. All right, now I'm going to choose another color. And it wants us to do small. It's going to be 53. 53 is less than 55, so here's 53. Let's do 63. That's the next number, right? That's greater than 55, so I'm going to put 63 here. And then the very last number is 73. That's it. Notice that the numbers go below the horizontal line, right? Now, let's go to B. Find the probability. So this is a probability deal. And so we're going to write the probability that it is medium. Okay, look what it says for medium. So we're going to write that in here. That's really nice. Is 53 is less than or equal to the weight is less than 63. All right, now remember what I told you. I think it's always really helpful to do the distribution. So my mean is 55, my standard deviation is 7, and I want to know here is 53, here is 63. I'm going to color this in. Don't color the one that you guys made for them, all right? Leave that one be. Make a new one. All right, so this is really good because it gives me my lower bound and my upper bound. I really think it's worth it. So I'm going to go to distributions. If you're on a TI 84, 83, you go to VARS, V-A-R-S, second VARS, and you see the distribution. If you're in the TI Inspire, it doesn't matter whether you go to probability or statistics. They'll have the distribution window there. Now, remember, we always go to normal CDF because I want to know for 53, 53.1, 53.2. C stands for cumulative. Always normal CDF. Now my lower bound is the first thing they ask for. That's 53. My upper bound is 63. My mean is 7, and my standard deviation, my mean is 55. My standard deviation is 7, and I do this, and I get 0.4859. So I'm going to go to 3 sig figs and say 48.6. Okay, or you could say 48.6%. Either answer is fine. Okay, now let's go do extra large. Okay, what does this say about extra large? So again, the probability that the weight is greater than or equal to 73. Okay, so I'm going to erase what I have here. Let me go to another color since I'm using a different problem here. Okay, so here's my distribution. Okay, I'm on a slant here. This is not good. And so my mean is still 55. My standard deviation is still 7. And 73 is greater than 55, so I'm going to go to the right, and I'm going to show greater than. Okay, that's greater than. So now I'm going to go to distributions, and I'm going to go to normal CDF. My lower bound is 73, but my upper bound is infinity. Remember, and the key for infinity doesn't work. So we're going to just put 1, 2, 3, 4, 5, 6, or you could put, just some big number here. And then my mean is 55, my standard deviation is 7, and I get 0.005, 0.005, and then it says 06. Okay, so that is my answer. All right, now it says here there's a probability that 0.3 that a random egg weighs more than W grams. Okay, do you see how this problem is backwards? This time they gave us the probability. They want us to find the weight. So this is going to be the weight. They said there's a probability that an egg weighs more than, so I'm going to use a greater than sign, and I have to solve for x, and it's equal to 0.3. Okay, so what I'm going to do, let's go erase this window. Let's go use another color. Okay, so here I'm going to draw my distribution, and again my mean is equal to 55. My standard deviation is equal to 7. All right, now remember when things have a normal distribution, the mean is the median. And what do we know about the median? The median. Okay, we keep on talking about the mean, but now I want to talk about the median. And that the median is that it's halfway, it's 50%. Well, we have 0.3. So I know that 0.3 is less than 50%. So this area right here is 0.3. But what did they want? They wanted to know more than. Okay, so what is that? That is 0.7. All right. All right, so let's go back to our window. So if you forget how to do this, think this through. Okay, take a deep breath, think it through. And we always go to to distribution, right? Now, if you go to the distribution, which one of those functions there do you think goes backwards, goes the opposite direction? And you see inverse norm? That's the one we want. See, so this will kind of help you along the way. Now, my area. What percent of my area did I shade? Did I shade 70%, correct? So put in 0.7. Remember, the area underneath the curve is always 1. My mean is still 55. My standard deviation is still 7. And so I am going to get x is equal to, and I'm going to get 58, and I get 0.67, so I'm going to say 7. And don't forget your units. All right, you guys, you need to know how to do z-score. I cannot emphasize this. This is new as last year. It's going to be on the test. I don't know if it's going to be on a paper 1 or a paper 2 question. Now, if you go look at the paper 1 question that I did today after school, near the end, there was a z-score, and I started at the end today. So you guys look at this. And if you have questions, save them for tomorrow.